Now we have talked about the one-dimensional motion. And we are going on to talk about the two-dimensional motion. So that or we can call it the projectile motion. But actually, a projectile motion is a very special type of uh, one-dimensional motion. Finding my wire. So projectile motion is a special type of 2D motion with constant acceleration. So there are a few examples that we are going to encounter later on, but so just give you a simple case first. Okay, so let's say if you are throwing a ball in the air. Okay, so this is obviously a 2D motion. Uh, and in this motion, at any point along the path, the object experiences the gravity towards the center of Earth, and then the magnitude, sorry, the direction is constant, and the magnitude of the force is also constant. So therefore, the acceleration is constant. It's constant g. It's 9.81. So in this is an example of the projectile motion. Just let's say if you're throwing any ball in the air, okay, without considering the air resistance, then it would be a projectile motion. So this is one of the example. So there another example, okay. So but we are going to talk about it later on. So let's say there's a slope here. So if you're throwing a ball along the slope, and then the acceleration is also constant. This g psi theta, okay, g psi theta. It's also constant. So and some other example is just like if a charged particle is moving inside a uniform magnetic field. So, but we are not encountered this kind of question in the commission, most likely. So I'll talk about this later on. There's one, I think there's one past paper regarding this kind of question, and then so although it's 2D, actually, there's nothing new that you need to learn. We are just using those equations of motion we've learned in the 1D motion. And then, but we'll apply the principle of the fundamental principle in the projectile motion. So that is a horizontal and vertical motion. They are independent. So what do I mean by they are independent? So that means you can calculate both motion separately. Okay. So that means actually you just consider the 2D motion as 1D that is horizontal and then another 1D that is vertical. Okay. And so that is the idea of this chapter. Okay. Then nothing special or nothing difficult actually. And then so let's uh so look at these five equation of motion. So actually we can write these five equation motion in vector form. And then because you know V, U, A, and S, they are vectors. So actually, for the first four equation, if you write down them with the head, so that is V U plus AT. U, V, A are vectors, and then you write down like this, and then uh, these are the formulas in vector form. But why I need to write them in vector form? Because if I write them in vector form, and then I finish teaching this topic already. So you just express everything in terms of I and j, because I hope you still remember. For any vector, it can be written as the something I plus something j, and then the r. Let's say this is a vector r. So Rx is a component of the this vector along the x-axis, and while Ry is a component of this vector along the y-axis. If you write down the final velocity, initial velocity acceleration in terms of the uh, vector form, then you just substitute in this equation of motion. Then you finish, okay, doing the projectile motion. And I didn't write down the last one because it's something non-trivial because there's a square here. We say that there are different types of multiplication in vector. So when you say it's v square, so what does it mean? Actually, here it means a dot product. Dot product. Okay. So later on we'll use this equation of motion in better form. Okay, later on, just later on. So we still will use the equation of motion in scalar form, and most likely in this chapter we are just going to use two of it. Okay, just two of it. Then it becomes very simple, is it? So most likely we are using the first one and then the third one in the questions. So let's have a look at the first general the first kind of projectile motion. That is projected horizontally. Okay, horizontally projectile motion. So what does it mean? It means that the initial velocity is horizontal. It will simplify the case a lot actually. So let me let that the initial velocity to be u, okay, and then it will follow a parabola in the space. Follow the parabolic path in the space, and then we are going to solve. We are going to find the final velocity, initial final velocity, and then displacement along the horizontal and along the vertical. So what does it mean? So what I told you is just we just use these two equations. And then, but we know that there are two directions. One is horizontal, one is vertical. So, and then we separate these two equations into two directions. So that's what I mean by the motion in the horizontal and vertical are independent to each other. So just most like very simple that I just write down the subscript for each vector. Because time is not a vector, okay? Time is a scalar. It doesn't have we don't have the time along the horizontal axis and the time along the vertical axis. Nothing. I, sorry. So let me explain what does mean by Vx, Vux, Ax, and then so on. So the initial velocity, okay, this is the initial velocity. So this is along the x-axis, is it? Along the horizontal axis. Let me also draw the axis in this question. So I let this axis to be x-axis, okay? And then because the object will moving downwards, so I let this one to be a vertical axis. And for the initial velocity, so because the velocity is along the horizontal axis, so the ux will be just equal to u, and the uy is equal to 0 because the initial velocity is horizontal. But after it moves for a while, the velocity is no longer horizontal at any point along its path. Then the velocity will have a horizontal component and the vertical component. So this is the final velocity. Okay, so this is called Vx and then it's called Vy. Okay, the vector. And then the x is the horizontal displacement. So let's say at this point, so let's say at this point, then the x is the horizontal displacement. This is the x, and this is the y, the vertical displacement. I use a symbol x for the horizontal displacement other than sx, and I use a symbol y for the vertical displacement other than sy. And then the acceleration is ax and ay. And but we know that for the acceleration, it's always vertical. It's always vertically downwards. So that means the ax is zero. There's no horizontal acceleration because the acceleration is downwards. And then the vertical acceleration will be just equal to g. Right. So then we just simplify the equation. Okay, substitute all we know about it. We know that ux equal u. We know that the uy is zero. We know that the ax equals zero, and then we know that the ay equals g, and so on. Then we substitute everything we know about it in the equation. Then the equation can be simplified like this. Uh, Okay, it's as simple as this one. So if we just look at the horizontal motion, sorry. So what you can see is the velocity does not change. The horizontal velocity does not change. It does not vary with time. It's a constant. Okay, it's a constant. So that's why we say that the horizontal motion is the motion with constant velocity because there's no acceleration. If you're considering the vertical motion, so you see the velocity, the vertical velocity will increase from zero with constant acceleration. That's g. So that is you can consider that motion as a free fall motion. And then we are going to try to solve one simple question first. So this is the first example. So you know that no equation is given in the question. So I hope you can write down or you can derive these four equations. These four, okay, these four. When you whenever you see the instantaneously when you see the question, okay, and then you substitute for this question, okay. What is given? Okay, you are given the vertical displacement. You are given the horizontal displacement, and then you're going to solve the time. You're going to solve the initial speed, and so you do the part A and part B first. Okay, then I hope you can derive these four equations by yourself. Okay, by starting from these two equation of motion, and then you separate these two into four, and then you just substitute all the initial values, that is ux, uy, x, and ay. Then you simplify the equation into these four simple equations. And then actually I'm almost done. So I'll give you time, maybe just five. I think you don't need 5 minutes. You do the part A and part B in this question. Find the time taken and then find the initial speed of the ball at the point A. Your time. Now I'll just write down those four equations here again. So Vx equal U. Okay, actually this formula is useless because it just tells you the horizontal velocity is a constant. You can't get anything from this equation, okay? So that means for the horizontally projectile motion, there's just three equation that you need to use. So another one is By equal gt, x equal to u times t, and y equal to half gt squared. So I just substitute what I know about it. Okay. So I just know about x and y. X equal 3 and y equal 0.4. So and I substitute it. X equal 3 and y equal 4, 0.4. You know the value of g. That's 9.81. You can't substitute as 10, okay? Just remember it. So what you can solve, how can you solve the time? I'm not going to use the first one because I don't know about the u and t. We can't solve anything from this equation first. So we are going to use the second one, okay? I think you can solve the time very easily from this one. I think June get the answer. Maybe. So the time is 0.286 in VSF. And then you are going to use the first equation to solve the U. That's 10.5 minutes per second. Okay. Then you have solved the part A and part B. Then what is the velocity of the ball B when it's at point B? Then how can we solve it? So at the point B, the velocity is not horizontal or vertical. So the velocity has two components. That's vertical. One is vertical, one is horizontal. So this is a Vx and this is Vy. So what is the value of Vx? We know that it's constant. It's just the same as the point at the point A. So it's still 0.5. Then the Vy, you're using the last equation, 9.x1 times time t, 0.286. Then this value is 2.x1, something like that. Okay, meter per second. But we haven't find the velocity yet. Okay, what do you mean by the velocity? Is not a component of x or y. It's a resultant one. Okay, that means the one that's using the Pythagoras theorem. Then we will get the time. We will get the velocity. So that is 10.9 meter per second. Okay. So any question for this one? Do you think this is hard? If you know how to use those equations of motion, I think it's not really hard to do this question. It's just substitution in the equation and then solve it. So I hope the first one is not really difficult to you, because the next one will be more difficult. So we go on to talk about the general projectile motion. So that means the velocity is no longer horizontal initially. So let's consider that there's a ball that's throwing at some angle with the horizontal initially. Okay, this is angle theta. So you know the ball will follow this kind of parabolic path. And then in this case, I still let the to the right position to be the x-axis, okay? And then the vertical axis to be y, okay, to be y. And still similarly, okay, the steps are quite similar. So we still starting from we are still starting from this two, and then separate into four. All the steps are quite similar. At UXT, okay. Lah, what's a different thing about it? So the velocity, the initial velocity, is not horizontal. So you need to decompose the horizontal velocity into two components. So one is along the horizontal. So this is a u cosine theta, and one is along the vertical. That is u sine theta. So be reminded that because we let upwards to be positive in this case, so this is positive u sine theta. If we let upwards to be if we let downwards to be positive, and it will become negative u sine theta. So we know the ux and we know the uy and substitute the acceleration. Okay, you know the acceleration is downwards. There's always the acceleration is g, but because it's downwards, so what I substitute is negative g. Okay, negative g, and then the horizontal acceleration is zero because the acceleration is neither horizontal or vertical. There's zero there. Then, so what we going to do, we just substitute the ux, uy, ax, ay in these four equations. Okay. You have a look by yourself. And then after this lesson, you need to know how to write down these four equations by yourself. So you have a look first. And then we are going to use these four equations to derive everything we need. Still the same trick. We still start from the first two equations of motion, and then just do it by divide into two directions, x and y, and then we substitute all the initial values we have. Then, then almost that's it. Any question here? Any question here? I think a few of you may find it quite confusing or quite difficult. So, do you have any question right now? Yes means yeah, you have question. No means you have no question. But if you have any question, you need to speak out, okay? Otherwise, I don't know. Even though you have no question, you may not be able to do the questions. Okay, that's fine. So let's have a look at what we are going to want to know about it. So let's say for this kind of motion. So obviously we want to find the maximum height. We want to find the time of flight. That means the time when it reach the ground again, and then the range of the path. Okay, so we're going to find this three, and then let me write down the four equation again. Similarly, the first one is useless. It just tells you that it's a constant. But you see that another three equation depends on the time. So starting from for maximum height, so that means like the other three equation depends on the time. So what does it mean? It means that you need to know about the time. If you know about the time at that point, then you can solve the Vy, x, and y. Okay, you can solve anything you like. So the main point for the projectile motion is to deal with the time. If you get the time, you finish the question. So for this one, at the highest point, so what is special at the highest point? You may say the y is maximum, okay? Yeah, the y is maximum at the highest point. So what does mean by y is maximum? Well, or what else? If you say y is really maximum, okay, you can't solve anything interesting from the equations. So actually, for the highest point, just like if you are throwing a ball upwards, at the highest point, the velocity is zero. At the highest point, if you are throwing a ball up vertical upwards, You can prove it very easily. Okay, let's say if the at the highest point, let's say the vertical velocity is not zero, so that means it can still going up. So that means that is not the highest point. So at the highest point, the vertical velocity is zero. Remember this condition. And then the velocity there's still a velocity. The velocity is horizontal. If you say at the highest point there's no velocity, then what we will do afterwards? It will just falling. Sorry, it will just fall vertically downwards. That means the path will look like okay, highest point, no horizontal, no horizontal velocity at this point, so it will fall vertically downwards. Is uh, nonsense, is it? So at the highest point, it's still a velocity, but it's horizontal. So that is u cosine theta. And then that's the u cosine theta, from the first equation. And then the velocity is u, and the angle is theta. So still remember, what we need to do is to deal with the time. So if you know the Vy is zero, then we are starting from the second equation, of course, because the second equation is the Vy. And then the vertical velocity is zero, and then we can solve the time. So that is u sine theta over g. And then what is next? So if we have solved the time, then we can substitute in the third or the fourth equation to solve the x or y. But in this case, we are not going to find x, that is horizontal displacement. We're going to find the vertical displacement, that is h. So what you do is you just substitute the time in this equation. Okay? Then you get that is u squared sine squared theta over 2g. I hope you know how to do this algebra. You can try to do it by yourself at home. Okay. Then next one, okay, we solve it. So next one we are going to solve these two together. So because these two means the same point, so this still it means the same point that is at this point, at this point. So we are going to find the time of flight and also the range. So for the time of flight, that is a time starting from the origin to the yellow point. And then what is the special about the yellow point? Can you tell me? So mathematically, okay, you can see that's one. This is our first special point. So what do we call it mathematically? What the point be? What do we call this point mathematically? You can type the answer in the chat. You know the answer. Okay. What do we call this point? Yeah, that is x-intercept. So what's special about x-intercept? That means y is zero. Of course, you can see at this point y is zero. If we turn to the ground, so that means that y is zero. Then what we can do it, okay? We can starting from y equals zero, or actually we can have another same condition. But we do it for y equals zero first. If y equals zero, we can use the fourth equation, okay? So I'll just give you 1 minute to solve the time. Well, I think you can get the answer by yourself, is it? From this equation. Now you solve two mathematically, you get two values. One is t is zero. Now you know this is you can consider it's a quadratic equation, but never do it, okay? It's just simple you can factorize a u. Sorry, you can factorize a time t. And then you solve either t is zero or t equal to 2u sine theta over g. Mathematically, t is zero is a solution. It means a point at the origin. Because initially the particle is at the origin, that's why it's zero. and then we can solve the time. So there's some special thing about the time here. I hope you're able to see it. So there is a time actually this time and this time. You see what is special about these two? It's just a double. It's just a double. Uh, it's not a coincidence because for the projectile motion, actually it's a symmetric motion. So this is a line of symmetry, line of irrational symmetry at this point along this line. So the motion on the left hand side and the right hand side are almost identical. The time are the same, the displacement are the same, the velocity, the magnitude of the velocity are always the same. Okay, so there's symmetry. So that's why you can see when you double this time, you get the time of flight. So then we have find the time. So you know the time is the king or the key for solving the projectile motion. And then we are going to find the range. The range is the horizontal displacement. So obviously, we are going to use this time to substitute in the third equation. Then you get there is 2 u squared sine theta cosine theta over g. Okay. Now, why I still write equation sign here? Because you can further simplify this equation by one mathematics identity. So that is sine 2 theta equals to 2 sine theta times cosine theta. Have we derived this one? We have derived this equation, is it? I forget about it. Okay. Then we have solved the horizontal range, the range. The last one we are going to solve is the trajectory. So what does mean by trajectory? So that means a path, the path of this motion. And that means that what does mean by the path? It means that you express the path independent. You expect the equation that is independent of time. So for trajectory, you're going to express the y, okay, in terms of the x and also independent of time t. So I'll just give you some time to think about it. So obviously we are going to use the third and fourth equations. And what does it mean by independent of time t? So that means you combine these two equations and to eliminate the time t. So that means you can simply do the substitution. Alright, substitution. Simply do the substitution to eliminate the time t. So I'll give you 2 or 3 minutes to do it. I'll just write down the equation here again. You use these two equations to eliminate the time t and see if you can get the answer. And then send send your answer in WhatsApp, maybe WhatsApp. You can write it on a piece of paper and then send to me in WhatsApp. So what you do by substitution? So you make t be the subject of the equation first, and then substitute in another equation. So I think there's no doubt that you're going to use the first one to make t be a subject. If you use the second one, okay, it will become is a quadratic equation of time t. It's very difficult for you to get the time t as a subject of the equation. So we use the first one So that is x over u cosine theta. And then substitute in the second equation, okay? So see what we get next. Okay, do you see it? So that's what we call by substitution. And then okay, cross out the u, and then you can simplify the sine theta and cosine theta by combine them as tangent theta. There's u squared. Sorry, there's u squared down here. So let me rewrite the equation in the next page. Okay. So you may remember this result by yourself. Yeah. So let me see if I have any page for writing down this one. Okay, let me use this space here. So the result is this one. You may think that this result is quite ugly, okay? But we are going to make it more ugly by using some identity. So we learn. Uh, I'm not sure if learned about this one before. So I think I didn't teach you. So the secant theta, so this is pronounced as secant, okay, secant, is defined as 1 over cosine theta. Cosecant theta is defined as 1 over sine theta. Cosecant here, okay. And then COT, this defined as 1 over the tangent theta. So this one is called the cotangent theta. And then we are going to derive two identities. So we know that we have one identity, that's sine squared theta plus cosine squared theta equal 1. Do you know about it? So let me ask. Yeah, okay, two of you say yes. So, okay, the two of you, do you know how to derive it? No? June, I think you know this equation identity. Do you know how to derive it? No? You can derive it from the Pythagoras theorem. So just draw a triangle here, okay? So A, B, C. So what is cosine squared theta plus sine squared? So that is cosine squared theta, that is A squared over C squared. Sine squared theta, that is B squared over A squared. So B squared over C squared. So that is A squared plus B squared over C squared. You know that A squared plus C squared is C squared. That's equal to 1. Okay? We have derived it, okay? Then you copy down on your book, your note, and then just memorize it as a law. Then what we can do, we can divide cosine square theta on both sides of this equation. So 1 over cosine is secant. Okay, 1 over cosine is a secant. So that is secant square theta. And then cosine square theta divided by cosine square theta, of course, is equal to 1. Sine square theta divided by cosine square theta, that is tangent square theta. Now these identities, we are going to use it very often in the commission. And then we can also divide by sine square theta in the equation, on both sides of the equation. So 1 over sine is cosecant. So 1 over sine square will become cosecant square theta. Then cosine square theta divided by sine square theta, you get cotangent square theta. Sine square theta divided by sine square theta, that's 1. Okay, that's it. So then we can simplify this, not simplify this equation. So we are making this equation more ugly. So 1 over cosine square theta, that is secant square theta. That's 1 plus tangent square theta. Okay. Oh, sorry, this minus sign here. So I'm not asking you to memorize the last formula, but you may need to memorize this one if you can't derive it, or you must need to know how to derive it. Okay, but if you can't derive it very fast, then you need to memorize this equation. We are going to use this equation very often in the later on Olympic questions, but for the last one, okay, it's quite useful. Almost, you almost need to use this equation. Uh, let's say this the A and this equation B. So equation B is more useful than equation A. So can you guess one reason behind why we need to further derive, well, further expand equation A to become B? So can you guess the reason behind? If you can guess it, then you know you have the idea how we use equation B. No? Anyone can? No one? Oh, my cat, she said she know. Do you know? Yeah. So the reason behind that, do you see the equation B? So it's not. You can consider it as a quadratic equation of x, and also you can consider it as a quadratic equation of tangent theta. Okay. Then it will be quite useful to solve some type of questions, especially regarding to the angle. So let's say if you want to solve the angle, or you want to solve something related to the angle, then you express in terms of the quadratic equation of tangent theta, it will be quite useful. Okay. Then, okay, I hope you copy it down first, and then we go on. Da, 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 da. So let's do something simple first. So this one, example 2, find the time, find the angle theta and also xy. So 1.2 is the time of flight. It go back, it falls back to the ground at the speed 6 meters per second here. So that means the initial velocity is also 6. Now, I send you what I've written down first. So I give you some time to. I think I shouldn't save it. Okay, it's fine. I save it. I give you some time to do it for example two, just 5 minutes. Okay. You have the time of flight, the equation of time of flight. You have the equation of range, and then I will see if what I want to see if you can solve the example 2 and 3 by yourself. Uh, so let me do the example two first. Where's my pointer? Here. Okay. So you have the equation of the time of flight. So that is u square psi square theta divided by g. But I hope you know how to divide it by yourself. So then let me try to solve it. So you get psi theta first. Don't forget to take the square root. Zero point 0.571, so 0.572. Okay. The angle I get. Ah, sorry, I used the wrong formula. So this is not the time of flight. The equation of time of flight is 2u psi theta of g. But I get. I, I will always press the wrong button. Yeah, the angle is 7.78 degree. Hey, I get 78.8 degree. So why you get 78 point? Hmm? Hmm? So you get 78.5? I don't know. So for the range, if you get the angle, for the range, okay, x is not a range, okay? X is the half of the range. X is just half of the range. Then you get the the answer is still. Eh? Why I always get the wrong different answer? I hmm? So June. The answer I get is 0.698. So may you check your answer later on? Yeah, yeah. So you check your answer later on. So I have no idea. Yeah, it should be 0.698 meter for the length xy because it's just half of the range. For example three, now let me draw it on the side view. Side view. The ball move it like this. So how long does the ball reach the maximum height? So the maximum height still have the condition that is Vy is 0. And then what is the horizontal distance travel when it first reached the height 2.8 up? around above the ground. So this is 2 meter, and then I think the maximum height should be larger than 2.8. So this 2.8 meter. So do you see why there's it say that first reach the height 0.28 meter? So because there's 2 point that reach the height 2.8 meter. So we are finding the this point or this point. Then that's it. Then you try to solve it. So in this case, what you know about it is just a vertical displacement. So the vertical displacement is not 2, it's not 2.8, it's 0.8 because it's moving upwards by 0.8. Then you just substitute in the equation, the fourth equation. Then you can solve the time. Remember, time is the key. You solve the time, and then you get the time, then you can substitute in the third equation to get the horizontal displacement. Okay, I think we stop here today. Because the later on question is Olympic level, so we need more time on Saturday to do it. So okay. So any question today? Now you go to solve finish example 3. You go to solve a finish example 3. So I'll also add one part for it. Okay, one part for it for part C. So find the time horizontal displacement. The velocity when the ball just before the ball when the ball reaches the ground. Okay. So I'll just add the part C, and then you finish this question, and then we can go on to the Olympic level of projectile motion next time. So see you on Saturday morning. Okay, it's 10 a.m. Bye bye. Bye bye.